So we're back. This is section 7 or 3.1, and we're just taking a look at some exercises from section 3.1. And so these numbers do refer to the exercise numbers in section 3.1 if you want to look at those and follow along. And so in the first example, we were given h of x, and we want to find an expression for h prime of x. Now you'll notice that this is two expressions multiplied together, and so we don't have that in our formula yet. We only have x to the n power, and so we need to break this apart before we do anything. So we need to FOIL first. And so x times 2x would be 2x squared, x times 3x would be 3x, minus 4x, minus 6. And so our h of x then, we can rewrite as 2x squared minus x minus 6. Okay, and now h of x is going to be easy to compute just using our power rule over and over again. So this would be 2 times 2x to the 2 minus 1 minus the derivative of x, remember, is just going to be 1, and then the derivative of minus 6 is 0. And so just rewriting that, that's going to be 4 times x to the 1 minus 1. Good, so this will be our derivative. By the way, I'm including this extra arithmetic steps here. You might include those until you're comfortable doing those in your head. Otherwise, it's good to just go ahead and write them down before you have to do that. That's fine. Okay, so similarly, in number 22, we have to do some pre-processing before we can actually compute the derivative. And so in this case, we have a fraction, so I don't know how to deal with a fraction. So I need to break this apart. And so the way we'll do that is that'll be x to the 1/2 divided by x squared, right? So that's going to be, so the idea here is I'm using the rule that a plus b over c is equal to a over c plus b over c. However, careful, you can't do it the other way, right? C over a plus b is not equal to c over a plus c over b. Okay, so in this case, we can write x to the 1/2 over x squared plus x to the 1 power over x squared. And now we can take that to be, well, I can go ahead and write this as x to the n power, right, in both cases. So in this case, this would be x to the 1/2 minus 2 power plus x to the 1 minus 2 power. So that would be 1/2 minus 2 would be x to the minus 3/2 power plus x to the minus 1 power. And notice I haven't done any derivatives yet, right? This is just rewriting the function. And so now I'm ready to write y prime. As notice that also I'm copying my notation here. This was h of x, so that was h prime of x. And when we have y, you could also write this as dy over dx, by the way. And so now if I differentiate, I get minus 3/2 x to the, what's it, minus 3/2 minus 1? Did you get minus 5/2 minus x to the minus 2? Good. So there's our derivative in number 22. All right, let's take a look at number 4 now. Y equals e to the 5th power. So what will dy over dx be? Let's see, it's going to be 5e to the 4th. Is that right? Did you say no? Are you screaming at me? No, no, no. It's going to be 0. Why? Did you recognize this? This is the constant e to a constant power. So this is a constant number, right? And so the derivative of a constant is 0. Good. So we only differentiate expressions in x or t. And so now let's see. This is number 52, so we're getting into the harder questions. For what values of x does the graph of e to the x minus 2x have a horizontal tangent? Well, when this says horizontal tangent, what does that mean in terms of your line? I think that means slope is 0 And so that means that the derivative of your function, if this is f of x, this means that f prime at some number is going to be equal to 0, and I have to figure out what the number is, right? What is x? Good, so we'll set the derivative equal to 0 and see if we can solve for x. So in this case, our f prime of x, derivative of e to the x is e to the x. Derivative of minus 2x is just minus 2. Good, and if we set this equal to 0 and solve, we get e to the x equals 2, or just take the natural log of natural log of both sides. So this would be the natural log of e to the x is the natural log of 2. So therefore, if x is equal to the natural log of 2, my derivative is 0. And so that means that my tangent line has a horizontal slope. Very good. All right. We're whipping right through these. No problem. The book also brings up the concept of a normal line. So definition, oops, I already have definition over there. The normal line is the line perpendicular to the tangent line. Perpendicular means what in terms of two lines? Two lines are perpendicular. Two lines are perpendicular or at a 90 degrees if the slopes are blank. Uh-oh, do you remember what that means? What that was? If the slopes are negative reciprocals. So what does that mean? That means, for example, if one slope is 1, oh, let me not do 1, how about 2? Then the slope of the line that is perpendicular would be minus 1/2. So when you multiply those two together, you get minus 1. So this is the negative reciprocal of that. That's the negative reciprocal of that. Yeah, and so on. Okay, good. So to find the normal line then, you have to find the tangent line, and then the tangent line gives you the original slope. Take the negative reciprocal of that slope, and you got it. Good. So let's see how we're going to use that in this problem. Find the equation of the normal line to the parabola that is parallel to this. Parallel to this line means that our lines will have the same slope. Okay. Now the normal line will be parallel to this, right? What is that slope? If I solve that for y, I'm going to get, let's see, that's going to be 3y is equal to x minus 5, right? So y is a third. And so this slope is 1/3, so therefore, what is the slope of the tangent line? Tangent line will have slope negative reciprocal minus 3. Good. Now we go back to our parabola and say, where on the parabola will we have a tangent line of slope negative 3? Can we figure that out? I think we might be able to. Let's see. Y prime will be 2x minus 5, I guess. We want this to be equal to, put a question mark, minus 3 for some x. Can we make it equal to that? 2x equals, let's see, add 5 to both sides, 2. Looks like x is equal to 1, huh? Good. So therefore, at x equals 1, what have we just shown? We've shown that the derivative is equal to minus 3. And so that will mean that the normal line will have slope 1/3. And so, let's see, now let's go to our normal line. The point that the line will go through is going to be x equals 1, and then plug it into this formula to get our y value. So if I plug 1 in, it looks like I get 1 plus 4 is 5, minus 5 is 0. So I get 1, 0. And then the slope of the normal line, it's parallel to this line, so therefore it was 1/3. Good. And so now we just have y minus 0 equals 1/3 times x minus 1. Perfect. Good. These two problems at the end here are kind of nice, but we're kind of running a little bit short on time, so I think I will break here, and we will take a look at numbers 64 and 67 in the next video.